Hello everyone, welcome to What the Math. In today's video we will learn about integration by parts and how we can use it to solve integrals where two functions are being multiplied together. So let's see how this actually looks like in an example. So we will start by solving this integral of x times e to the x with respect to x. As we can see, we have two functions multiplied together, which is x and e to the x. If it was any of them on its own, we can easily get an answer. For x, for example, it would be just 1, or the integral of e to the x would be e to the x, plus the constant of integration in both cases. But in this case, we have both functions, we have the product of these two functions. So to solve this, we need to use integration by parts. Let's start by writing the general formula, and let's see how it actually looks like. So if we have an integral, let's say u times v dash, we can rewrite this integral as u times v minus the integral of u dash times v. So this is the general formula of integration by parts. It kind of looks like we've made the integral harder, but we will see how this actually helps us to solve this integral. So what is u and v? This is where we need to choose which one of the two functions over here is u and which one is v. So let's start by writing somewhere separate what we choose as u and what we choose as v dash. In this case, we will choose x to be u and e to the x to be v dash. We will talk in the next example about how we can choose which of the two functions to be u and which one to be v dash. For now, let's just see how we can apply the formula to solve this integral. So once we choose, the next step is to differentiate u and integrate v dash to get u dash and v. So if we differentiate u, this one over here, we get 1, the derivative of x with respect to x is 1, and now we need to integrate this one over here, e to the x, and the integral of e to the x is just e to the x. So now let's continue the integral and let's apply the formula. So first thing we need to do is write u times v. So we need to multiply u times v over here. So we get x times e to the x minus, because of the minus over here in the formula, the integral of u dash times v. So we need to multiply u dash times v. U dash is just 1, so we not really need to write it. And v is e to the x, and don't forget dx. So what do we notice? We get a term on the outside, and now we are left with this integral over here, which is just the integral of e to the x with respect to x. So let's continue over here. We need to rewrite this term. So we write x e to the x minus, and now we need to solve this integral, which is just e to the x plus c, the constant of integration. And this is basically our final answer. X times e to the x minus e to the x plus the constant of integration. Now, let's try and solve a harder integral and see how we can go about and choose which of the two functions we need to choose as u and which one we need to choose as v dash. So let's solve this integral of e to the x times sine of x dx. So how do we choose our u and how do we choose our v dash? The way to do this is we need to remember this kind of word over here. L stands for logarithmic, I stands for inverse trigonometric, A stands for algebraic, T stands for trigonometric, and E stands for exponential. So what does this really mean? It just means that we choose U to be the function that appears earlier in this list, in the Liate list, and dv to be the rest. So in this case we have e to the x times sine of x. We have the function e to the x and sine of x. If we look at the list, which one? This is an exponential. This is an exponential. And this is a trigonometric function. So which one comes first in our list, in the LIATE list over here? We notice that the trigonometric comes before the exponential. So we choose u to be sine of x, the trigonometric function. Let's see how this is gonna help us out to solve this integral. We have u v dash. So we said we will choose the trigonometric function to be our u, so this is sine of x, because it comes first in our list, and v dash is e to the x. Then we need to differentiate u. So what is the derivative of sine of x? It's just cosine of x. And we need to integrate v dash or e to the x, and the integral of e to the x is just e to the x. So let's apply now the integration by parts formula. I'm gonna rewrite it over here so we can just remember it. So we have u v dash u times v minus the integral of u dash times v. So let's go down here and apply the integration by parts formula. So first u times v, u times v, sine of x times e to the x minus u dash times v, u dash over here and v is over here, so we have minus the integral of u dash, which is cosine x, times e to the x dx. Okay, so again we have an integral of the product of two different functions, so we need to apply the integration by parts formula one more time and see what we can do from there. And so if we do it once again u v dash, if we remember our list from earlier, we have trigonometric and exponential, and again the case is the same. We have a trigonometric function over here, cosine of x, and an exponential e to the x. So we will use the trigonometric function, which is cosine of x, to be our u, because it comes first in the list. So our u is cosine of x, v dash is e to the x, u dash is the derivative of cosine of x, which is negative sine of x, and the integral of e to the x is e to the x again. So we need to apply the integration by parts formula once again. So we write again whatever we have at the front before the integral, which is sine of x e to the x minus, and let's open up a bracket. So we have u times v which is RU is over here, RV is over here, so cosine of x times e to the x, so we get cosine of x e to the x minus the integral of u dash times v, so the product of these two, so we get negative sine of x e to the x dx. So if I continue and apply the negative sign from here as well, we have sine of x e to the x. Let's distribute this negative sign over here inside the brackets. So we have minus cosine of x times e to the x, and if I apply this negative sign again, we have, so here we have a negative sign outside and we have a negative sign inside the integral. So if I apply this negative sign here, it will become a plus, and if I apply this one after it, it will become a minus. So we are left with minus the integral of sine of x e to the x dx. So now we could use integration by parts again, but we're not gonna get anywhere. We have to notice something, and what we notice is that this integral over here is the original integral that we started with. And if we go back at the top and we see our integral over here, we can set it equal to I, for example, and we can replace this whole expression over here with I. So we can say that I is equal to sine of x, just rewriting what we have above, minus cosine of x e to the x minus I, and we need to add the constant of integration because we removed the integral. What we need to do now is take this I to the other side, and we get that I, this I from above, plus another I is equal to sine of x times e to the x minus cosine of x e to the x plus the constant of integration. I plus I is equal to 2I sine of x e to the x minus cosine of x to the plus the constant of integration. The next step is to divide everywhere by 2, so we can get rid of the 2 on the left hand side. Now we could divide the constant of integration by 2 as well, but that's just another constant, so we can just leave it as c. So these 2 and these 2 cancel out, and what we are left with is, I just made up some space so we can write it above. So what we are left with is I is equal to sine of x e to the x over 2 minus cosine of x times e to the x over 2 plus the constant of integration. And we can simplify this further by saying that by taking these outside, we can factorize both of these, and if we factorize them outside, we say that e to the x over 2, we open the bracket, sine of x minus cosine of x plus the constant of integration, and this is our final answer.